All right, so we're going to get this kicked off, another edition of KETIV AVA, and today we're talking about design states or model states with a sheet metal designer. So my name is Grayson. I've been on here now a couple times. Going to be hosting this event, and then I'm also joined by Jammie. So he's going to be a new face for today. So Jammie, if you want to go ahead and introduce yourself.
Sure. Hi, everybody. I'm Jammie Seepaul, Application Engineer for KETIV. Fairly new. I've been here for about 2 months. I can tell you a little bit about myself here. I'm a mechanical designer for a little over 10 years. So I've worked in oil and gas industry, heavy duty truck and trailers, rail car manufacturers. I've worked from the shop floor using saws with raw material, CNC machining, and then all the way up to designing downhole completion tools for oil and gas.
Okay, yeah, so I'll take it you use sheet metal a little bit.
Oh yeah, sheet metal.
Yeah.
Mechanical designing.
Cool. Yeah, so as usual, as we go through this webinar, feel free to shoot off questions. I'm going to be monitoring the chat, and then I'll either be answering those live, deferring to Jammie for some of those answers. And then, yes, feel free to shoot off questions. I believe we're also going to have a few polls throughout this webinar itself, so feel free to answer those. We've got a few questions that'll pertain to the material that we're talking about today. But other than that, yeah, Jammie, go ahead and take it away.
Thank you, Grayson. All right, so for the agenda, we're going to talk a little bit about the general rules working with sheet metal, things to look out for when you're designing. We're going to talk about the new feature in Inventor 22, which is model states. And I'm going to run through a quick demonstration, and then we'll have a Q&A at the end. So general rules for working with sheet metal. Whenever I'm designing parts, I like to think about, what do we have to use for tooling, machines, knowing their capabilities and tolerances so you can have a productive design. There's been times in my career where I'm tasked with designing a new part, and while I'm designing the part, I might not know exactly what our machines can do, and sometimes that can backfire and cause you time on the job. So really getting these things, up front, knowing what your design is going to be and the intent really helps you with a productive design. The other thing to know with sheet metal is there are some standards working with sheet metal with parts. You don't want to put holes or features too close to bends or too close to the edge of the part, because then you can have a part that will fail. So just be mindful of your company's standards or industry standard for sheet metal when you're designing your part. So design states or model states. So, this is design states for the sheet metal designer. So what design states are to me is, in manufacturing, you have a process to creating your part. So while creating that part, now with the new feature in Inventor, you can actually represent each step of the manufacturing process, all within one Inventor part. You can use that even further to create a fabrication drawing, which shows each step while still only using one part. So it makes it really simple to get across how you want your part to be manufactured. There's times where you're going to send parts out to the vendor, and they might create the part to what they thought would be the best process. And when you get the part back in shop and you measure it and you do your QA, you see it's not a tolerance. And a lot of times you'll find out it's because they use a different process to create your part. So this will really be a big benefit for a lot of companies when they need to make fabrication drawings. It'll save the designer a lot of time.
Okay, so Jammie, so you use design states more as like a manufacturing guide. So we're going to do, bend A first, then bend B. Maybe we'll then go put it on do some punches. It was just mainly for like a guide.
Correct. Yeah, it's just you can almost take your manufacturing process as is, whatever your company standard is, and create that in different states and steps within Inventor now using model states.
Yeah, that's pretty cool.
Yeah, so today I'm going to be, designing a part that goes on this. So this is a suspension for a heavy duty truck and trailer. I'll be designing the left side one part to show you how you can utilize model states with sheet metal. So I'm going to jump over to Inventor. And I'm going to create a new part, a new sheet metal part. All right. The first thing I like to do when I'm working with sheet metal, and I'm going to cut the video real quick. Maybe this will work a little bit faster. First thing I like to do is to set my sheet metal defaults. So today I'm going to set my thickness to 1/4 inch, and I'm just going to use some generic type steel for the material. I'm going to change this to represent some steel as well, so it'll look a little bit better here for y'all. I'm going to create a sketch.
Out of curiosity, Jamie, so when you're going through the process of like defining your internal standards, you're putting in your company standards into sheet metal, does like the material choice, K factor, all of that come into play?
It does, but Inventor has some really good defaults set up for your K factor. So choosing the material that you're actually going to be using can actually affect your tolerances whenever you're going to bend. There are many things that can affect your bend, especially how you're going to bend, what press brake you're using, what tool you're using, but it's good to actually have your material set correctly. That way the K factor can be accounted for.
Okay, that's good to know.
All right, so I'm going to create a sketch here for a part. It's going to be a rectangle, so I'm just going to put it here on the XY plane. And we'll put a rectangle here. Good little tip is whenever you create a rectangle in Inventor, it pops up these boxes so you can type the dimension right in. This is going to be a 16, and then I'll hit tab and by 30. And it saves you a step in having to go out and dimension the rest of this box. It's fully constrained now, so it's kind of a one-step deal. So I'll finish the sketch. And I'll click on face. So face is just going to use the sheet metal defaults that we had set previously. You can choose which way you'd like it to create the face. I usually just choose both sides, so it'll place the plane directly in the center of the part. Okay. So here's model states on your browser. So it starts with a master state. I'm going to create a new state here. So this will be our first state for this sheet metal part. Just your raw sheet that's cut to size, that you're now going to go to the next step and cut the actual shape of your part. So in doing that, I'm just going to create a new state, which will be our second state. And I'm going to create a sketch on this face. Now I have the sketch here on another screen. I'm just going to copy this to save us a little bit of time. But I'm just going to paste that here. And you can see another little thing here is I know the sketch is in place where I want it to be, and just to lock it down, I'm going to use the auto dimension feature to apply 13 dimensions, which will then fully constrain the sketch. I'll go finish sketch. And for here, I'm going to go to the 3D model tab and do an extrude. This new dialog box, I'm not sure what you guys are using, if it's an older Inventor or a new Inventor, but I really like this because it kind of puts all your features right where you need them. So the distance here, I'm just going to go through all. Just going to want you to select what you'd like to cut. So I'll select those two sides there, and I'll hit OK. So there's our cut and our second model state. So when I'm thinking of the manufacturing process that this part's going to go through, it's raw material, and then we're going to go to cutting out the shape of the part. From there, I'm going to want to put a bend in this part. So I'll add another model state. So we're in our third model state. And we're going to make a sketch on this face. And I'm going to draw a line. Now, when using sheet metal, and I'm going to do a fold for this bend, you have to make sure that this line is exactly where it needs to be and touching each side that you're going to bend. So it needs to be coincident with this side. It's purple, so it's not constrained. So I'll throw a dimension up and I'll call it 8.5 inches. I'll finish the sketch. Okay, and now I'm going to go to fold. Back on the sheet metal tab. I'll hit fold. It wants to know what direction you'd like it to fold. It wants to know the bend line. So the bend line is right here. And this kind of gives you a preview of what's going to happen. I would like the fold to go the opposite way, so I can flip the control right here. I'll just press OK. And here we have our bent part, our third model state. I'd like to add one more model state. Oh, go ahead.
Yeah, we actually just had a question come in from the panel from Bennett, and he was wondering why use an extrude versus, say, like the sheet metal cut tool. Would there be, one preference of one over the other?
Honestly, I just prefer the 3D model cut. The sheet metal cuts usually, if I know what exactly the machine's going to cut or the path of cutting the sheet metal, then that kind of comes in play because that brings over a little bit extra information for you. But right now, this is just a generic cut, so I'm just going to use a 3D cut.
Okay, yeah. Because I know that in the cut tool, there's a special option in there for cutting around bends, so I can see that being useful. But if it's just a generic cut on a flat profile, like extrusion or cut's pretty much the same thing.
Exactly. Thank you for that question. All right, so I'd like to add one more model state here. And for this state, I'm just going to throw in a couple slots. This is just to show you how we can actually use the model states, not only for the manufacturing process, but also when we put this into an assembly, we can have a little bit more variation in our part. So for here, I'll just create a sketch on this face. And I'll just select the slot, and I'm not too concerned with the size or anything right now. So we'll just call them a 1/2-inch slot. I'm just going to lock them down, finish this sketch. And again, we could do a punch. I'm just going to go back to the extrude because I don't know the process or what really would be relevant for that information. I'm going to select the faces I'd like to cut. I can say cut here, or I can say through all, and it'll know exactly where I need to go. So now we have 4 model states for this part. So we started with the raw material size, and then we cut it to the designated shape that we would like. Then we put a bend in the part, and then we just added some cuts. So showing all of this is great, but say you need to send this part to a vendor, or you have a shop and they're wanting to know, hey, how do we create this? A really good, easy way to represent this is creating a drawing that will then show
Jamie, I had a quick question for you real quick on the model side. So I know we went through the process of creating each of the model states. What about editing them? Like, I've gone through this whole process. I've got my manufacturing decisions, but maybe I want to move something around, say like a given feature. Is that something you're able to do? Like, what does that kind of look like?
Yeah, great question. So it's really great with model states because you can make edits to them. You can make add features, take features away. And the way that works is, say we wanted to change this feature. When you activate one of these model states, it'll represent what work you did or did not do within that state. So as you can see, if I go to the model state 4, we did the extrusion. Now, say we wanted to go into this model state and add a feature, and I'll just do it. Well, I'll do one real quick. I'll just put circle right here. And we'll do a finish, an extrude cut. Okay, so we just added this feature to model state 3. If I come into model state 4, it's not going to be there because I didn't have it when I created it. Now, say you do.
Oh, interesting.
Right.
Okay.
You can come in and you can turn that on. Or if you wanted to come in here, everything's still in your tree. It just suppresses the
Mm-hmm.
feature. So it's very, very, very flexible.
Okay, yeah, that's useful. So everything's done through feature suppression. Like, does it still support? Because I know, like, when you're say like you're modeling inside of a generic inventor component, you can move around when features occur. So, for instance, if extrusion 2 wasn't reliant on a specific geometry that came before it, you might be able to move, say, extrusion 2 all the way up to before face 1. Is that something that model states will still handle?
Yes, yes, you can definitely
Okay.
do that.
Okay.
That's a great question. I appreciate it.
Yeah, yeah. I mean, to me, honestly, like model states, they really feel like design views, right? So if you're in an assembly and we create design views as opposed to level of details, you can pick or choose what components are being shown in any given state, right? It feels like they went ahead and they've incorporated that into models, and then just now we're leveraging features instead of components.
Exactly, exactly.
Okay.
It's a big feature, and I think it's really gonna make a lot of designers' lives easier after this.
Yeah, yeah, absolutely. I mean, I'm just trying to think of my time when I was in industry when we were doing a lot of, say, component design. You know, a lot of the times we'd have to get into manufacturing processes, just even outside of sheet metal. This would have been awesome to have.
Yeah.
One more quick question for you on the model states. Can you rename those so you can put in the steps versus just having like 4, 3? Okay, awesome.
Most definitely. You can't rename the master step, but you can rename everything.
Yeah. Okay, we got a couple. Well, now we're getting a few questions about modeling. So Carl, he asks if we can use model states to reverse folds in order to create mirror models, so left-right positioning. It sounds like more like a feature manipulation than necessarily like a capturing of a specific instance. I'm not sure if you can answer that.
That's a great question. I think you can. We can. Let's see here. So if I unfold this and fold it the opposite direction, let's even try it here. Edit feature. We'll flip this way and say okay.
And then create a new model state.
Yeah. Yeah. No, it's not
Yeah.
going to.
Okay.
You have to create.
Yeah. So it looks like it's always taking the immediate data out of a feature and showing you that state. So that's a good question, Carl. That'd be interesting to see if you can have like positional representations using model states, but it doesn't seem like that's something you can do.
Yeah, great question. Great question.
Also, somebody else is asking just really, what does the master look like? So we have all these different model states. Is the master just the initial creation?
Yes, it is.
All right. So I guess that is your I guess material, like your stock material.
Right. The reason I went ahead and created a model state 1, a new state, is because it just gets a little confusing when you come in with a master and then you have, especially because I'm not renaming each of these states. So it would have said like master 1, master 2, master 3, 4, but really this would have been master 1. So if you rename the model states, then the master, you can just assume that's your initial design state.
Oh, and then while we're on the topic of the master, Rodney was asking if we can put, holes or slots on the master after they've been created, so we can then cut them apart.
I have not tried that, but we
got some interesting little workflow conversations going on right now.
I'm very curious to see what this will do. I'm gonna break some stuff. Let's go back to the master. Let's do it.
Oop, I'm going to flip that around.
Hey, there we go. Oh, no.
Oh, interesting.
Yeah, it doesn't take a feature.
So I'm wondering if it's just, maybe when we created that model state, some of the boundary information is not there. it's interesting, right? Because traditionally, when you have a master level of detail, it incorporates everything, or even like the design views, especially when you're inside of assemblies, like master is as it currently resides, but they almost use master as just like the initial create point, and then everything else is built on top of that as you go through the model state. Yeah, somebody named Michael, he just came in, he's like, the whole might happen somewhere else.
Right, right. I mean, I can take it here to the fourth step. Yeah, it doesn't look like it's going to take it anywhere. But I know so when you're working in assembly, the master is just everything. It's just one big file.
Yeah. No, so one of the interesting things about these kind of conversations is really just how you start applying these tools, right? Everybody's got different workflow processes when you're doing your day-to-day job, and it's really about trying to leverage these tools in the best way possible. If you have specific like workflow questions, these are things that we can help you out with on a case-by-case basis, just because I feel like a lot of the questions that are coming in right now is because you're doing these current things in your day-to-day job, and this model state might be piquing some interest in how we can best apply it. So feel free, absolutely, after this webinar, to reach out to myself, to Jammie, and we can help you kind of identify, why are you looking at doing this? Are there instances where you want to try to have multiple components in one part? I'm even personally curious about multi-bodied solids in model states. Like, how can we start leveraging these two things together? It's a pretty interesting tool.
Yeah, it gets even more interesting on the assembly side, but let's see.
We're not going to get there today.
Yeah, I'm not sure we'll get there today, but I'd really like to show the drawing side of.
Okay. Yeah. So we'll put a pause real quick on some of the modeling stuff. Let's go ahead and hop over into the drawings real quick.
So in the drawing, if you'd like to really have a great way to present each manufacturing step, the great thing about model states is you can put in a view, and I'll just put in an ISO view. You can change the states from within your drawing. So here we have master, which is the raw material. And that's great. Okay, what's the next step? Well, we'll go ahead and drop another view in. ISO model state 1, and it just throws up the very next state. So we're doing this all from one inventor part. So it's kind of, you can kind of see it as like configurations of one part within inventor. It really cuts the time down, the space. You're not creating 5 different parts to just show one manufacturing process. So you kind of get it there. We're going to come out, we're going to put another one, we're going to do 3, which is the bend. We'll put one more. Lost the 4 there. And obviously you can come in and change the title of the step, put some pertinent information for your manufacturer or vendor. Like I said, sometimes you send parts out to vendors, at least when I've been working in my career, and you send out your drawing thinking you've covered everything and you know what you're going to get in the end, and you get your part and you go out to QA and you check it out and it's not what you wanted, and it's usually because they're using a manufacturing process that you did not design to. So that's where model states really comes in. Very useful, simplifies your job a little bit with having to show this process. And I think it's going to be a real powerful tool. Let's see, I got some more questions coming out there.
Yeah, I'm just reading through some of these. Tony had a good point of like, hey, if you went ahead and created everything up front and then used model states as a way to do snapshots backwards. So basically, like, hey, we do everything up front, and then we use maybe the, the end of model or end of feature X that's in the browser tree, like move that up, do a snapshot, move it maybe down a couple steps, do another snapshot. Our master would then be the finished representation as opposed to like the initial like material that we're going to be using.
Yeah, that may work. the reason I created it this way by step is I'm not having to go manage my features in the tree afterwards. But I guess if you wanted to utilize your master to show the end product instead of, you know, your initial raw material, that probably would work.
Yeah, it's, you know, it's one of those things where Inventor is such a general tool. One of the things that I think companies struggle the most with is how to properly apply it. And, you know, there's a million ways to get the same thing done. And, you know, this is just really kind of a conversation that comes up. Okay, do we do everything up front? And then I iterate back through and I try to figure out how I want to get this thing built. Or do I want to take a different approach and build it as I go, right? And think about what some of those steps are going to be so that I'm not designing a part that can't be manufactured. You never want to send something out to the shop and then they come back to you like, hey, we can't really build this.
Exactly.
There's another question too that came in about IDWs over DWGs. I mean, from my understanding, it's, you know, IDWs really just start incorporating a lot more of like the inventor functionality, but you'd still be able to open up IDWs within AutoCAD. DWGs are also just a more widely accepted format. So sometimes if you're sending these things off to various vendors, there's a lot of software will read in DWGs as opposed to an IDW file. To me, they're basically the same thing. It's just who's, you know, voice of customer, who you're trying to send these out to. I don't know if you have any input on that, Jammie.
You hit the nail on the head there. That's exactly what I would say. I'm just using the Inventor drawing template now because we're in Inventor, but DWG is like you said, it lends itself to many different software, and you know, definitely if you're going to be sharing or going back and forth, DWG would probably be the way to go. Okay. Well, we got our part created, and I'd like to, so I think we're okay on time. I'd like to put it here into this assembly. So this is just an assembly, partial assembly of a suspension hanger. And I've created a reinforcement model state. And so I would like to put in this new part I created. We'll go ahead and take it to model state 3. And I'm just going to do a copy paste. So here's the part. It's going to be constrained to the top of this part and to the side of this one. So I'll just throw that up real quick. Also, a little tip is in Inventor, you have these little glasses, which is a preview, and this little kind of looks like a measuring tape. So if you have this checked, it'll keep your item exactly where you had it whenever you go to make a constraint. If you have it unchecked, it'll just assume a flush made. So I kind of like keeping that checked so I can watch the part move. But it's really just your preference. Sorry for spinning a lot. I know it's probably might make some of you dizzy. Okay, so we got the part locked down. So where design or model states comes in with an assembly is you can start to show, you know, different configurations of one assembly within one Inventor assembly model. So for instance, say this setup is for a 10,000 pound suspension, and a customer comes back and says, hey, you know, we need the exact same suspension, but we need to be able to carry more weight. And say a solution to that would be adding a backing plate and some hardware and maybe some features here, which you can then weld in to reinforce this assembly. So you can show all of that using model states. So I just created this state here, which is a reinforcement. And you can see I added that part in the master state. So it's not going to include it on here, but I can come in and I can check for it to unsuppress. and it'll show up on this state now. Also, we go into this part, you can see all the states that you created initially. So we're in the reinforcement model state right now. And I'm going to go ahead and just turn on this fourth state. Now, if you'll see, when I go back to master, it's taken away the features for the hardware and the backing plate, and it's taken away the slot cuts on this part. So it's managing the model states within each individual part in the assembly. That's huge, because now you're not having to recreate an entire assembly to show that, you know, hey, we could add some features, add some parts, and it can really be dynamic in what you're trying to present to the customer.
You know, this also brings up, so there's another question that came in, mainly, I guess, a statement about being an improved level of detail. And this is something that I try to talk to people quite frequently about, is the differences between, say, level of detail, design views, and now, I guess, model states. What I tend to find is that people use level of detail to remove, you know, parts or pieces from the screen. Either like, hey, we're going to take this out of the bill of material for a given instance, but it really functions off of suppressing components, which has its own, how do I put this, its own dangers, right? Most of the time, you should be using design views to control what I'm seeing at certain areas. So this might be, hey, you know, I created a design view, so when I go to place this part on a drawing, I'm only seeing this specific piece or this IPT file inside of the drawing. A lot of the time, people use level of detail to kind of accomplish that, and it's just unsuppressing and suppressing components is not something you want to try to get into the habit of. Design views really kind of take that role. Now, when it gets into model states, I'm really curious to see kind of how you've been going through this assembly to see how we can leverage those on top of one another. So we have, say, model states in addition to design views without necessarily having to even get into level of detail.
Right, right. And actually the model states is replacing level of detail. But one other thing I was going to show is we still have representations. And if we bring this down, you can see I created hardware representation. So, you know, I threw some hardware in and created that representation within this assembly. You can see some hardware showed up here. So if we go into the reinforcement, the hardware stays because it's a representation. So that's just another thing to note, you know, if you're going to continue to use representations, because you can leverage model states and representations in your drawing views. So just be mindful that, you know, whatever you do in your representations, whichever one you have selected in the phone is going to stay no matter what model state you take it to.
Okay. And then there was one question that came in a little bit earlier, and it was around punch feature IDs. Is that something that Inventor 2020 or 2022 can handle inside of the folded model view, specifically around the drawing?
I believe it can.
We'll probably have to check on that.
Yeah, we'll have to, you know, we'll take that question down and we can get back. Okay, so let's go back to my PowerPoint. All right, so just a recap of what we've gone over. We went over a little bit of general rules, working with sheet metal, you know, knowing where you're placing your features, your holes, your cuts, your bends. We went over knowing your manufacturing process and your tools and their capabilities when designing a part. Before you start designing, preferably, you know, you have a timely design, a productive design. You know, you don't want to put too many bins in a part, not knowing what tools you have. You may not be able to make those bins, which, you know, has happened before. I've seen it. We went through the model states in Inventor, which I think is a very powerful tool. It's gonna make a lot of designers' jobs easier. And we went through a demonstration, which I hope wasn't too spinny or confusing. I'll go ahead and open up to any more Q&A. This is my contact information, the email, and our support number for KETIV.
Yeah, there's actually something came in through Rodney again, and it was interesting. So when it comes to sheet metal, typically you can get a flat pattern out of it, right? Can you have a flat pattern per model state? Or like how does that work?
That is a great question. I have not attempted to make multiple flat patterns in one inventor part.
Yeah, I'm curious how that would change if you'd have like different, if you'd have multiple flat patterns, if it would be, so normally like flat pattern is a final item, like after you're getting ready to send it out for manufacturing.
Right, exactly. That kind of it seems like it would be really nice, but I'm not sure that's something that it'll be able to do, but I'll have to go test it. So definitely we can get back to you, Rodney. Let's see here. Also, I could throw up a link for anybody who may want to brush up or is new to Inventor on sheet metal, working with sheet metal. We have an AVA, Inventor 101, working with sheet metal, that I'll throw up in the chat there for everybody.
Okay, that would be good. There's another couple of questions coming in. One through Array. Is there any improvement on the thickening tool to prevent normal direction from flipping back and forth? I'm pretty sure that functions off of like an A side definition. So I don't know if maybe there's a different way of representing it. Have you used that tool too much?
I haven't used it in year 22, so I'm not sure if they've changed anything.
Okay. That's something we'd probably have to take a look at least specifically under the sheet metal functionality. There's also another interesting one from John. So is there an Inventor 2022 update coming for export sketch as from a flat pattern of an unfolded model? So I guess that if it's too complicated, then Inventor 2022 may crash. I'm trying to think of a flat pattern that would be too complicated to export a face. Hey, that's interesting. We'd probably have to see that part, John, so we can take a look and see what's going on there.
I definitely like to see exactly what he's trying to accomplish, so we can, that's just one of those things is, the process in which you're going to create your DXF for the flat pattern. If it is complicated and crashing, then, maybe there's another way to do it. I'm not seeing any new questions rolling in.
No, it's like we've had quite a few coming through. So I mean, it was good to see all the dialogue. Rodney's been having a few more questions about just things we can do with flat patterns and explicitly model shapes. Rodney, I'd fully recommend reach out to Jammie, get on a phone call with them. That these are things that would be much easier to discuss really kind of just in person on the phone. Sometimes trying to work through workflow stuff is a little difficult when it's just through a chat window.
Yeah, definitely, Rodney. Shoot me an email with your questions, and we could connect and we can go over those together.
All right. Well, this is one of the shorter ones. I think we made it through pretty quickly in 40 minutes. But again, as always, if anybody has any questions, you feel free to reach out to Jammie. He's got his information right now. Definitely a cool AVA. I believe next session, Javier, one of our other application engineers, he's going to be showing model states in a bit of a different context. So not necessarily within sheet metal, but doing a deeper dive on maybe how you use this with traditional IPP files instead of Inventor. So expect to see that next week.
Yeah, definitely stay tuned for Javi's session next week. He'll be showing a machine to part, so different from sheet metal. And yeah, I appreciate everybody attending today.
Oh, bill materials, IAMs, Vault. Yeah, he's going to be showing all sorts of cool stuff. But thank you again for everybody for showing up today. It's been a pleasure. And let me know or let Jammie know if you guys have any questions. We'll talk soon.
Thanks, everyone.